Do that one dance, baby. That one dance.
Hi everyone! So today I am going to answer those questions. So question number 1. What is reaction rate? So reaction rate is a measure of how quickly the reactants in a reaction change into the products of the reaction. Question number 2. What are the factors that affect reaction rate? Explain each factor. So there are 4 main factors that affect the reaction rate: the concentration, pressure, temperature, and surface area. So concentration. Concentration is a measure of the amount or number of particles in a given volume. Concentration can be increased by either increasing the number of particles while keeping the volume the same, or by decreasing the volume and keeping the number of particles the same. This means increasing the concentration increases the rate of reaction. And pressure. Gases can be compressed while solids or liquids cannot. Pressure, therefore, only affects the reaction rate of reactions involving gases. This means increasing pressure on reactions involving gases increases the rate of reaction. And temperature. Particles need a certain amount of energy, called activation energy, for the collisions to be fruitful, in other words, for them to react. Increase in the temperature increases the average kinetic energy of the particles. This means that more of them will have sufficient energy to react, results in more fruitful collision per second, and therefore an increase in the rate of reaction. This means increasing temperature increases rate of reaction. And surface area. To understand this, consider the reaction between hydrochloric acid and one marble chip. The H3O plus ions from hydrochloric acid can react with only the surface of the marble chip. If this marble chip is broken down into two, the total mass will remain the same, but the surface area will have increased. The H3O plus ions from hydrochloric acid can now react with more of the marble chip in a given period of time. This means that increasing surface area increases rate of reaction. Question number 3. What is chemical kinetics? So chemical kinetics, or reaction kinetic, is the scientific study of the rates of chemical reactions. This includes the development of mathematical model to describe the rate of reaction and an analysis of the factors that affect reaction mechanisms. So Peter Weg and Cato Goldberg are credited with pioneering the field of chemical kinetics by describing the law of mass action. The law of mass action states the speed of a reaction is proportional to the amounts of the reactants. Question number 4. How to measure the rate of a chemical reaction? The rate of chemical reaction can be measured in 2 ways. The first way is to measure how quickly the reactants decrease, and the second way is to measure how quickly the products increase. Question number 5. How to speed up the rate of a chemical reaction? A chemical reaction occurs when the molecules of the reactants collide with one another in the reacting environment. The rate at which a reaction occurs depends on the rate of the collision of the molecules, and the collision rate depends on various factors which can be altered to change the rate of a reaction. The reaction rate can be increased by the action of one or more of these factors. So there are 4 ways to speed up a chemical reaction. First, use a catalyst. A catalyst is a substance that can alter the rate of a chemical reaction. Catalysts can be successfully used to increase the rate of a chemical reaction. Also, catalysts are subjective in nature, i.e., a catalyst works specifically on certain reactions only. A catalyst is not consumed in the reaction, and it does not change the products of the reaction. For example, decomposition of potassium chlorate starts at 302 Fahrenheit in the presence of manganese dioxide as a catalyst. Otherwise, in the absence of the catalyst, this reaction is a slow process, which starts at 715 degrees Fahrenheit. Second, increase the temperature. For most chemical reactions, temperature is directly proportional to the rate of the chemical reaction. Therefore, increasing the temperature increases the rate of the reaction to a certain extent. But precaution is needed while increasing the temperature of the reaction to avoid accidents. For example, the dissolution of sugar in water takes place faster when water is hot as compared to the rate of dissolution in cold water. The increase in temperature increases the energy of reactant molecules, making them move faster and more susceptible to collisions, thereby increasing the reaction rate. Third, concentrate of the reactants. The concentration of the reactants also plays an important role in determining the rate of a chemical reaction. According to the collision theory, for most of the reactions, increasing the concentration of the reactants is known to increase the rate of the reaction. When more reactants molecules are available, more collisions takes place, increasing the overall rate of the reaction at the same conditions. In the case of gases, the concentration of the reactants can be increased by increasing the pressure of the reacting environment so that the same reactants molecules become more concentrated. Fourth, increase the surface area of the reactants. Increasing the surface area of the reactants increases the rate of the reaction. More surface area means more collisions of the reactant molecules and an increased rate of the reaction. This occurs when the reactants are made to react in powdered form. For example, powdered sugar dissolves more quickly in water than a lump of sugar. Also, in the case of combustion, the reaction is very fast when the fuel is in the form of fine particles or in the form of a powder. Question number 6. Explain collision theory. So, collision theory explains why different reactions occur at different rates and suggests ways to change the rate of a reaction. Collision theory states that for a chemical reaction to occur, the reacting particles must collide with one another. The rate of the reaction depends on the frequency of collisions. The theory also tells us that reacting particles often collide without reacting. For collisions to be successful, reacting particles must collide with sufficient energy and with the proper orientation. Question number 7. How important is the speed of reactions in forensic investigation? The speed at which a reaction takes place can be very important to the results of the reaction. Within the area of forensic investigation, the part of the investigation most concerned with the speed of reactions is the investigation of death. Both the time of death and the chemical processes that takes place after a person dies are of great interest to an investigator. A chemist can use his or her knowledge of what happens chemically to a body after a death to assist in pinpointing both the method and time of death. So that's all, and I hope I answered all those questions. Thank you and God bless.